Hi everyone, how are you all? So I hope you can hear me. So we were just discussing few questions in CN and then I will just continue with few more questions, right? So let me just quickly recall you that what we were discussing. We were discussing about the flow control mechanism and then we talked about that two protocols like what is stop and wait, what is sliding window protocol. In particular sliding window we talked about go back and selective repeat, right? Now, there were two things. One is that transmission time. Another one is propagation delay, right? And I hope you know these two delays. And then we talked about RTT. What is RTT? RTT is generally total round trip time that we take, right? So which is including your transmission time, queuing delay, or anything else, right? So this is RTT. Now, we talked about very interesting thing, which is this. See, if you have this much time in your hand, and actually you have this much time, right? So to just send one packet from one sender to destination, how much time it takes? Suppose if I just ask you that you want to send one packet from here, from this sender to receiver, then how much time it takes? What do you think? This is the sender. This is receiver. And there is one packet that you want to send. So total from the moment you start transmission till it gets to the completely gets to the receiver, it take TP plus TT time, right? It takes this much time from the start of the transmission till it gets to the receiver. It takes this much time. Now, if you ask me that how much time you total take from the start of the transmission till you get the acknowledgement completely, then you are going to take plus TP time extra. Why? Because for the acknowledgement you are going to take this much propagation time extra. You may also take transmission time for the ACK if it is given in the question, right? So why I am writing this time? This time is basically the total time for any packet from the moment you start the transmission till it gets completely to the receiver. This is the time that you take, right? And then if you are also sending the acknowledgement, then you are going to take TP plus TT, which is if it is given for the ACK, then you will be writing it, right? Now, given this much time in your hand, there are two things that they may ask you, that how many number of packets you are sending, then you need to divide by TT. And this is very important number. They may ask you how many bytes you are sending, and this is also very important number, and this is called bandwidth delay product, right? So if they ask you in terms of bytes, you multiply by the bandwidth. If they ask you in terms of packets, you divide by TT. And given one of this, you can also convert to another one. Like, I mean, you know that these many bytes you are sending. If you want to convert that to a packet, you just divide by L, and this is just 1 upon TT, right? You just divide by L. That's all you need to do. So basically, this number is very important, and that is called bandwidth delay product. That is basically bandwidth into delay. Delay is RTT here. Right? So these many bytes, in terms of bytes, if I just ask you, I mean, it depends on whether bandwidth is given in bytes or bits, but yeah, in general, I'm taking bandwidth in the bytes. So in terms of bytes, I can say these many bytes, right? So you can say that these bytes, these many bytes, you can send these many bytes you can send in RTT time. Similarly, if I just ask you how many packets you can send in RTT time, if RTT is, let's suppose, 2TP plus TT, then in this much time, how many number of packets you can send? Number of packets, then it will be 2TP plus TT divided by TT. These many number of packets you can send, which is actually coming out to be 1 plus 2a. And if I ask you number of bytes, then also you can do it, which is bandwidth into delay product, which is RTT, and RTT is given to be 2p plus 2TP plus TT, right? I hope that is clear to everyone, because these two numbers are very important. Yeah, hi Sumant, good afternoon. Hello Ratul, good afternoon. Now Ratul is asking, TT if the length of, yeah, that is okay sir. When the ACK is sent after the reception by the data link layer or the network layer? Okay, so it depends that we are using protocol at which layer. So if you are using this protocol, which is the selective repeat protocol or go back N protocol, then at the data link layer, now we are talking about only a data link layer. Okay. Now we will be using the same protocol in case of TCP. Then you will be sending this ACK from host to host, from end to end. Like in one of the video, like I mean in one of the course video, I talked about that how all layers work together. There I talked about it. Like whenever you are sending a packet from one one host to another host, and let's suppose this is the final destination that you have, right? Then in this case, you will be sending the ACK from data link layer to data link layer, data link layer to data link layer. At every hop you will be sending. But once it reaches to the destination, then at that time you will be sending from transport layer to the transport layer, right? Only one transport layer to transport layer ACK happens. Otherwise, the data link layer acknowledgement happens at every hop. That we talked about in one of the video. Okay. So I hope this picture is clear to everyone that for this given time, which is RTT, if someone asks you number of packets, then how to calculate. Someone asks you number of bytes, then how to calculate. If this is clear, then things will be smooth for you, right? Another thing is that we talked about the throughput. Throughput is very important. We can define throughput in terms of any unit. Let's suppose I'm saying bytes per how much bytes per second, or maybe packets or bytes, right? Packets or bytes per second, or maybe per unit of time. So you can say that you can define a throughput in any term, maybe bytes or maybe packets. Let me write or here. In one unit of time, how much bytes or packets we are sending, that is called throughput. Efficiency is that what we can actually do, right? How much packets we are sending, how much packets we are sending, and in the given time, how much number of packets we could have actually sent. Or maybe in terms of, you can find out the efficiency in terms of like bytes also. How much bytes you are sending, this is just one packet, which means L bytes you are sending. And how much bytes you could actually send, you could have actually sent these many bytes, right? So you could have actually sent these many bytes, and you are just sending L bytes, so that's why this is efficiency. And that is same as the earlier picture, which is TT upon this L upon bandwidth is TT upon 2TP plus TT, and again this is 1 upon 1 plus 2A, right? So now you see, in just one formula, or maybe you can say these are the three formulas, these are the three interpretation that we are doing. Efficiency is number of bytes we are sending upon we could have sent, right? Number of bytes we could have sent. Now, see, there is one more very interesting observation about the efficiency, which is number of time, or maybe like how much span of time we are using, right? Span of time, or just time we are using, because we are just using the transmission time. Once we transmit, sender is just idle, right? Sender just keep on waiting. The sender is working just for this much time, and time we are using is this much. Time we actually have is this much, right? In terms of time also, you can calculate the efficiency. Time we have in hand, right? In terms of packet also, you can talk about the efficiency, and all of this is same. Like number of packets you are sending, packets we are sending, right? I hope it is visible. uh, can you please quickly confirm, or let me just adjust it a little bit? Okay, so I hope that is visible, my slides are visible. Now I'm saying number of bytes we are sending upon number of bytes we could have, sorry, number of packets we are sending, number of packets we could have sent, number of packets we could have sent. So you can talk about efficiency in any terms. Maybe in terms of time, maybe in terms of bytes, maybe in terms of packets. All are efficiency, and all formulas are just one form of another, right? So I hope that is very much conventional to everyone. Okay. So let me know if that is clear. That number of bytes, in terms of number of bytes, number of time, like how much time we are using, or number of packets, all of this is just efficiency formula. Okay. And now there is one more term, which is throughput, that we have defined is like number of packets, number of bytes per second, right? Maybe 5 packets per second, 300 bytes per second, 200 packets per minute, like that, right? So we can define throughput like that. Now, since we are just sending one packet, in 2 TP plus TT time, and we are just sending one packet, so you can find out the throughput. Or maybe L bytes, you can say in terms of bytes also, you can say L bytes. So the throughput will be L upon 2TP plus TT. Or maybe yeah, I mean in terms of packet also you can find out, which is 1 upon, this is bytes per second, like this is the throughput, you can say bytes per second. If someone say that, okay, tell me the throughput in terms of packets per second, then this is the throughput in bytes per second, then you can also find out the throughput, this is the bytes per second, and then you can also say the throughput in the packet per second will be like one packet you are sending, or maybe you can write in that way, that in 2TP plus TT seconds you are sending L bytes. Okay, in terms of bytes it will be something like this. Then in 1 second you are sending L upon 2TP plus TT, right? These many packets, these many bytes, sorry, bytes. So which means this is throughput, which is these many bytes you are sending in 1 second. So that's throughput. Now, similarly, you can talk about throughput not in terms of just bytes. You can also say that in terms of packets, right? I mean, it is just number of bytes per second or number of packets per second. So you can say that you are sending just one packet. So in 1 second, you are sending 1 upon 2TP plus TT packets. So these many packets per second you are sending. So this is also throughput, right? I mean, depends on the unit you are using. This is also throughput. This is also throughput. Both are throughput. L upon 2TP plus TT is also throughput. 1 upon 2TP plus TT is also throughput. But now you will say, like, there is a difference of L, right? There is a difference of L in both of the formulas. Yeah, but the unit is also different, right? So here here it is packets per second, here and there it is bytes per second. So that is why, like, you can calculate the throughput in any terms. I hope that is clear. So it should be clear cut in your mind that you should, instead of remembering these formulas, you should be clear cut in your mind that what is the throughput and what is efficiency, right? And now we can basically define the relationship between throughput and efficiency, which is coming out to be throughput equal to uh, efficiency into bandwidth, right? So what is efficiency? How much efficiently we are using, so how much total we have, I mean that will be in the numerator, and how much denominator, and how much we are actually using, that will be in the numerator. So basically total, like you can say efficiency in terms of time, total you have, right? Total you have TT time, sorry, total you have 2TP plus TT time, and then you are just using this much time. So in terms of time, this is efficiency, and all of this is same actually, right? Because efficiency does not have any unit, so that's why all of this is same. In terms of, like, let's suppose in terms of packets, I say that how many packets you are sending, just one, but what you could have actually sent 1 plus 2a. So in terms of packet, it is the efficiency, and since it does not have any unit, that's why all of this is actually same. And in terms of byte also, you can say L bytes you are sending, but how many bytes you could have sent, bandwidth into delay product, which is 2TP plus TT, right? So all of this is actually same. This is efficiency, okay, in terms of bytes. So in terms of time, in terms of packet, in terms of bytes. Similarly, the throughput is basically the total time that you have up, like I mean sorry, throughput basically the number of bytes per second, right? So, or maybe number of packets per second. So maybe you can say that you in 1 second, like in 2TT, in this 2TP plus TT time, you are sending L bytes. So that's why L upon 2TP plus TT bytes per second. So L upon 2TP plus TT bytes per second. And it is also, throughput is also equal to, so you can say throughput is also equal to, in terms of packets per second, which is this, like in the denominator it will be always the time, because you are having the packet, it is one packet. So that's why in this you are saying that this is throughput packet per second, right? And now finally we relate this efficiency and the throughput with one to each other. How? Using the bandwidth. So we say that throughput equal to efficiency into bandwidth. So I hope these three things are clear to everyone. Should be clear cut to everyone, and there should not be any confusion in these three things. Right? Okay. So I hope that's fine. Now let's just move to the questions that we were talking about. So here in like in efficiency in terms for the selective repeat, it will be window size, sender window size upon 1 plus 2, right? Efficiency will be this much. Why? Because you are basically sending these many packets and you could have sent these many packets. Okay. Now just answer me one question. Just answer me one question. Suppose, suppose we keep on increasing bandwidth, then in selective repeat or maybe sliding window, any of the sliding protocol, efficiency will always increase. Is this true or false? What I'm saying, if you keep on increasing bandwidth, just think with the common sense. Okay, suppose you have the infinite bandwidth. Okay, between the two channels you have the infinite bandwidth, suppose. Then would you be having the 100% efficiency? Your efficiency will always increase, or maybe it after a certain time it will not increase. I mean, will always increase, and obviously the maximum value is 1. So what do you think? Let me know. See, if you keep on increasing the bandwidth, then after a certain time, what will happen? That you are limited by some number of packets that you can send, right? And what is your limit? Your limit is depending on how many packets you can send, depending on the sequence number. If sequence number is, let's suppose, n bits, then you can send. If sequence number is n bits, then your window size could be 2 power n minus 1 only, right? In selective repeat, it will be 2 power n minus 1, something like this. So you are limited by your window size. Even though the bandwidth is too much, but you do not have enough sequence number, then what you will do? You are limited, right? Yeah, if you have flexibility for the sequence number and the bandwidth both, which means you do not care about the sequence number, you do not care about the bandwidth, then in this case your efficiency will always be 1, right? Because efficiency depends on two things. One is the sequence number, one is the sequence number. If the sequence number is you don't have, right, doesn't matter how much bandwidth you have. If the sequence number is just 1, which means your window size is, let's suppose, just 1. Okay, your window size is just 1, then doesn't matter how much bandwidth you have, you can only send just one packet. That's how the protocol is defined, right? So it is basically depending on the sequence number. At the same time, it is also depending on the bandwidth, right? So if your bandwidth is, let's suppose, very less, but your sequence number is too high, then what's the use of the sequence number? Because you are limited by your bandwidth. If your sequence number is, let's suppose limited, which is 1, bandwidth is too high, then also there is no point of having a high bandwidth, because you can only send, let's suppose, one packet. So that's why it depends on two things. And what is the actual formula? The formula is this, right? The formula is this. So here it is depending on sequence number. I mean, sequence number means the window size, right? And yes, it's also depend on the, so in this A, the bandwidth is hidden, right? So it's also depend on the bandwidth. Yeah, obviously it depends on many other factor, but I'm just talking about these two factors overall. Like generally, like people think that, okay, if we keep on increasing the bandwidth, then the efficiency will increase. No, it depends on the sequence number. If you have the limited sequence number, then it may not increase, right? Okay, so now let's talk about questions. So yesterday we solved some good questions. Now today we are going to even challenge ourselves more, and we will be solving even better questions, right? I mean, like everything is good, but it's just that maybe bit more difficult questions will come today. Okay. So I hope my screen is visible and everything is fine. So let's just continue. Now what they are saying is that the station A uses 32 byte packet to transmit a message to a station B. So there is a station A that is sending a packet to station B, and the packet size is 32 byte. Using a sliding window protocol, the round trip delay between A and B is 80 milliseconds. So what is round trip delay? Everything, right? I mean, it now it includes everything: the transmission delay, propagation delay. If there is a queuing delay, then also it includes in the round trip delay. So it is 80 milliseconds, they are saying. And the bottleneck bandwidth on the path between A and B. So there the bandwidth is given to be 128 kilobits per second. So you need to be careful here. So kilobits per second it is, right? So which means 128 into 10 is power 3, and since it is bits, so that's why you need to convert that to a byte. So maybe you can divide by 8, or maybe you can convert that to a bit. Anything is fine. So maybe let me divide by 8. So now it is just bytes per second, right? I have removed the kilo also, so it is bytes per second. Cool. Now what they are asking is that what is the optimal window size that A should use? Can you do this question? So bandwidth is given, RTT is given. So now tell me, can you quickly find out how many, like, I'm not sure if that is asking question or not, but let's not worry about it. Like whenever you see the bandwidth and the RTT, then can you quickly find out one thing? What is that? Bandwidth delay product, right? Can you quickly find out what is the bandwidth delay product? Using these two, bandwidth into RTT, which is called bandwidth delay product, which is basically, okay, which is 80 millisecond. So since it is millisecond, that's why 10 to the power minus 3 into the second, into RTT is 128 into 10 to the power 3 upon 8. So this is bytes per second. So ultimately it will be just a bytes, right? So this will tell you, so this is 10, and then I think this is 1280 bytes, right? 1280 bytes. So what it is telling you, can anyone tell me what is this bandwidth delay product? Now you should be very, very clear that what is this bandwidth delay product. Just let me know in just one line, what is this bandwidth delay product telling you? Yes, Ratul, you are correct, but I'm just going with the intuition. So what is this bandwidth delay product tells you? It tells you that what is the maximum number of bytes, right? Maximum number of bytes you can send in this RTT, right? Number of bytes you can send in this RTT. Basically, you can fill this channel. You can fill this channel with these many bytes, and not just one way in the RTT time, which means in the two ways. So basically, these many bytes maximum you can send. So these many bytes you can send. So basically 1280, these many bytes you can send, and since 32 bytes is your packet size, so you can say these many packets you can send, right? So I think this is 40. So 40 packets you can send. Now this is coming out to be 40. So they are saying that what should be optimal window size? See, you can send 40, then why to limit ourselves, right? Why not send 40? So that's why B is the correct answer. I hope you understood. So what I'm saying is that you can send 40 packets. Why? Because you calculated using the bandwidth delay product, and bandwidth delay product is saying that you can send 40 packet. If you can send 40 packet, and then they are asking what is the optimal window size that you should be using, then obviously if you can send 40 packet, then why to limit, right? So you will be sending the 40 packets. So that's why B is the correct answer. I hope that is fine to everyone. Okay. Yes, Rahul, that is correct. Capacity, yeah. Sumant, yeah, that capacity, I don't know. Like capacity is basically the channel capacity will be just A, right? I mean, it might be just one way propagation delay or maybe something like that, right? But RTT is telling you that in two ways, right? In total time, like how much you can fully pack the channel, not in just one way, okay? This way and this way also. I mean, the moment you are sending the packet, you keep on sending till you get the ACK, right? So number of bits that can be sent max, yes, that's true. Number of bits or number of bytes depends on the unit. Okay, so cool. So I hope you understood this. Now let's just move to the next question. Yeah, B is the answer. Okay, now let's just go to this question. What they are saying, station A needs to send a packet or a message consisting of 9 packets to the station B. So they are saying the station A wants to send 9 packets, right? So let me just write it, maybe 1 2 3 like that. Total 9 packets is want to send using a sliding window where the window size is just 3. Yeah, that's very interesting. So in one go you will just send 3 packets, but total you want to send 9 packets. All packets are ready and immediately available for the transmission, which means you do not need to wait for the transmission to occur. I mean, for the upper layer to give the data, all packets are automatically ready. But there is a problem. The problem is that if every fifth packet that A transmits get lost, but no ACK from B ever get lost, so they are saying that every fifth packet you are losing, then what is the number of packets that A needs to transmit to send the 9 packets? So if you want to send 9 packets, then 1 2 3 4 5, right? So window size is 3. Now this 5 will get lost. Now interestingly, since the 5 is getting lost, and they are saying they are using the sliding window protocol with the go back end, right? So with the go back end means like you will be having here the window size is 3, so you will be sliding it, and since the 5 will get lost, so in this case what you will do, you will say that 1 2 3 4 5, you must have sent 5 6 7, right? And since 5 is getting lost, and this is go back n means like you will get the acknowledgement of 5 first, then only 6, then only 7. It's not like that you can get the acknowledgement of 6 in between, right? So anyway, since the 5 get lost, so you will not get the acknowledgement for 5. So you're stuck here. Can you move your window? Obviously no, right? You cannot move your window. So you will get stuck, and then your transmission timeout will get expire, and then you will think that okay, since this 5 is get lost, so that's why you need to again send this 5 6 7, right? But they are saying every 5 packets get lost. So this is from starting, this is 5. Now again you need to count, then this is 1 2 3 4 5. So this 7 will again get lost. Since 7 is getting lost, and then along with the 7 you must have sent 7 8 9, right? So because of that you need to send 7 8 9 again. So now 1 2 3 4 5. Now this 9 will get lost, and then you need to send 9. Is this okay to everyone? Now let me know how many packets you are sending total. I think total you are sending 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So you are sending 16 packets in total. Let me know if that is clear. Sumant is saying bandwidth into propagation delay is capacity. Yeah, you can say that is capacity. Capacity means the channel capacity that you can fill it with, right? So yeah, that is capacity. That you're correct. So Ratul is asking one question, sir. Uh, if number of bits of the sequence number are given, then optimal window size will be the minimum of the answer you calculated, and then 2 power n. Yes, yes, that's correct. I mean, so what was the answer that I collect? Okay, see, you are asking. Let me just go to that question again, and then let me see that what you are asking. A second. So I hope. By the way, this question should be clear to everyone, right? So we are sending the packets, and every 5 packet is getting lost. So this is how it is happening. Now, uh, now in this question, what they have asked, they have given the RTT, they have given the bandwidth. So it means that these many maximum packets we can send. And then Ratul is asking one question. Let me just copy this question there here only. Okay, because that question seems a little interesting, so that's why I'm just copying it here. So what he's saying that number of bits of the sequence number is also given. Let's suppose they give you that okay, n bits you have with the sequence number. See, the 40 is the maximum that you can send in this given time, right? And the n bits you can have, which means the window size can have, I mean, the 2 power n minus 1, or whatever, right? It depends on the protocol. Let's suppose 2 power n minus 1. This could be your window size. I mean, this is the available sequence number that you have at the center side, right? Available sequence number at the center side, or maybe let me just say that this should be your window size. So this is the maximum you can send. And let's suppose that that you cannot send more than this, right? More than 2 power n minus 1. Let's suppose this is just 10, this is just 10, something like that, right? Maybe just 15 or something like this. Okay, let's suppose this is just 15, and then obviously you cannot send more than 15, although you should have sent 40, but since you are limited by this, that's why you cannot send more than 15. This is one thing, right? But there could be another scenario where let's suppose this itself is a huge number. Let's suppose this itself is 64, right? If this is 64, then can you send the 64? Then obviously no, right? Reason being is that in the given time, the moment you send this 40 packets, the moment you finish sending the 40 packet, then at that moment only, see, the moment you finish sending the 40 packets, this is the 40th packet that you are sending, this is the 40th packet, and that the same moment you will be getting the ACK of the first packet. So you cannot send more than this. Yes, that is also correct. So yes, your argument is correct that you need to send by the minimum of the answer we calculated, because this is the maximum packet we can send in the given time. But now we need to see with the sequence number. If the sequence number is greater, then also we can't do anything, because we can send this much only. If the sequence number is lesser, then since we are limited by the sequence number, that's why we need to send with the sequence number. Yes, that was the nice doubt, and yes, you are correct, Ratul. Okay. So now let's move to the next question, which is this one. I hope these questions are making sense. If there is any doubt, you can just ask me. Now, what they are asking, the distance between two station M and N is L kilometers. The all frames are k bit long. So they are saying that the distance is given to be L kilometers. So let me just write D equal to L kilometers, and then all frames are, the length is also given, okay, which is k bit long, that is okay. The propagation delay per kilometer is t seconds, okay. So for 1 kilometer the propagation delay t seconds, but since this is l kilometers, so that's why I think the total propagation delay, so let me just write the propagation delay will be this much, how like this much seconds you will be taking for the total l kilometers, right? Because per kilometer the distance, the propagation delay is given to us is t seconds, so which means that for the l kilometers you will be taking these many seconds, okay. Moving further, let r bits per second be the channel capacity. So they are saying r bits per second with the channel capacity, which means that what is the channel capacity? So since it is given in the bits per second, it must be the bandwidth. Bandwidth is given to us, which is r bits, in the bits it is given, okay, per second. Assuming that propagation delay is negligible, sorry, processing delay is negligible, the minimum number of bits for the sequence number field in the frame for the maximum utilization. So minimum number of bits for the sequence number, okay. So they want to have the maximum utilization. So let's just find out that how many packets you can send. Maybe you can send bandwidth into, if you find out the number of packets, I think that should be one. Like you can do one thing, bandwidth into delay product, that will give you number of bits, and then you can divide by the packet size. The packet size is given to us, which is k bits, right? So bandwidth into delay product will be r into what is delay? Delay is here 2 TP 2 TP plus TT. TT is your propagation delay. Sorry, transmission delay. So what is the transmission delay? Which is length upon bandwidth, K upon R. This is your transmission delay, right? So this is number of bits. These many bits you can send, but in terms of packet, I can just divide by the length, which is K. So in terms of packet, these many packets you can send. So you can say these many packets you can send. Since these many packets you can send, that's why you can find out the like, I mean, you should be sending, actually, if that is allowed to us, then you should be sending it. So which means that based on this you can find out the what should be your minimum sequence number, such that it should be allowed. If the sequence number is just maybe 1 bit, then maybe it is very difficult to send these many packets. So this is the number of packets, right? Now I think if you calculate it, you multiply by the r maybe, or r by k, you multiply by the r by k, it will be 2 lt r by k plus 1, which is actually same as 1 plus 2a, right? If you find out 1 plus 2a, that is same as 1 plus 2a, because 1 plus 2a is the number of maximum number of packets that you can send. 1 plus 2a is maximum number of packets that you can send, maximum number of packets we can send in the given time, in the RTT time, right? So now like, instead of directly using 1 plus 2a, can anyone guess that why I have went through this bandwidth into delay product? See, like, I mean, I have no intention to do something like this. The only reason why I did in like this is because sometimes they give you the propagation delay, sometimes they give you the queuing delay. So if you just use the 1 plus 2a, then you might get confused that how to use this formula. So that's why instead of directly using the formula, I have just derived that formula, right? I mean, it is fine to directly use this formula in this question. Reason being is that they have not given the queuing and propagation delay and these things. But if they give you the queuing, propagation delay and these things, then using this formula will not be much suitable to you. Then in this case, you might need to go through the procedure, which is bandwidth into delay product. That will tell you number of bits or number of bytes. Then you divide by the length of the packet. That will tell you number of packets that you can send. So this is the maximum number of packets that you can send. Now you should not limit yourself with the number of bits only, right? With the sequence number. So that's why, if this is the number of packets that is allowed, so take the log of this, right? Take the log of this. That will tell you the number of bits that you should be having, such that you can allow these many packets, right? So log of this number. Um, yeah, I think 2 LT R on K plus 1. So I think C is the answer, right? Let me know if that is clear to everyone. Okay. So I hope that is fine. So C is the correct answer here. Its answer is C. And yeah, you can use the formula, but I prefer to use bandwidth into delay product. That's very nice things. Okay, bandwidth into delay product is very nice. It just tell you what is the maximum you can do in the given delay, in the given RTT, right? In this given delay, what is the maximum bits or maximum bytes you can send, and based on that you can find out what the maximum packets you can send, and then you just found out it. Yes, 1 plus 2 is the directly ready-made formula for the maximum number of packets that you can send. That I completely agree in the given RTT time, but sometimes they give you the propagation delay and all that. Then in that case this formula may be a bit confusing to you. So I mean, it is up to you how you are using, right? I hope you understood what. Okay, so now let's solve this question. What they are saying, the frames of 1000 bits are sent over 10 to the power 6 bits per second duplex link between two hosts. Okay, so length is given to us, which is 1000, over a 10 to the power 6 bits per second duplex link. So which means the bandwidth is given to us, which is 10 to the power 6 bits per second. The propagation time is also given to us, which is TP, it is 25 millisecond. The frame are to be transmitted into the link to the maximally packed them in the transmit. So see, whenever bandwidth and okay, length and from this data, can you quickly calculate the bandwidth into delay product from this data? Bandwidth into delay product. Tell me, is this possible for you to calculate bandwidth into delay product? I think it is possible. Why? Because bandwidth is given, which is 10 to the power 6 bits per second. Okay, it is in the bits per second. So let me write it, bits per second. Into delay is 2 TP, which is 50 milliseconds. Since it is milliseconds, so that's why I'm multiplying by 10 to the power minus 3 plus TT. TT is length upon bandwidth itself, right? So length, which is 1000 upon bandwidth, which is 10 to the power 6. So this is again in second, and this was also in second. So I think things are fine. So this is bandwidth into delay product, right? Now let me just simplify this, and that will tell you how many bytes you can send. So I think these many bytes you can send. So with these many bytes, you can also calculate how many packets you can send, right? Okay. Bytes or bits, sorry, it was bits. So they are saying the minimum number of bits that is required to represent sequence number. I think this is the same as the earlier question. I don't see any difference. Okay. So what you can do, like you can divide by the packet length. What is the packet length here? Length is 1000. This is divided by 1000, and this will tell you the number of packets. Okay, this will tell you number of packets. So let's just calculate it. Since this is 10 to the power 3, so what you can do, maybe you can just simplify this numerator first, which is 10 to the power 6 into 50, which is um, like 5 into 10 to the power 4 plus, because this is, yeah, 5 into 10 to the power 4 plus 10 to the power 3 upon 10 to the power 3, it is 50 plus 1, this is 51 packets. So these many packets you can send in the given time, right? So these many packets you can send in the given. I hope you understood. Now, once you find out the packets, what they are asking is that what should be the sequence number bits. See, I mean, this is very nice. I mean, in the sense that you have the capability, you have the capacity to send 51 packets. Then I mean, the channel is so nice. The channel is providing you the capacity. I mean, these are the properties of the channel. Channel is providing you the bandwidth. Channel is giving you the propagation delay. Channel is giving you the transmission delay, right? And what is in your hand? I mean, as a host, what is in my hand? I can have as many sequence number as I want, right? I mean, depends on me and the receiver, like agreement between we both, right? So obviously, right? I mean, if I have the liberty to send 51 packets, then why not? So I will not limit myself to have just to send just one packet. So why will I be limiting? So that's why I will take the log of this, and whatever is the number coming out, I will say that that is the answer. Okay. Just a second. So why it is 25 frames? Propagation time is given to be like this. Bandwidth is okay. Propagation time is 25 millisecond. must send 10 to the power 6 bits into the channel in the second, which means, okay, they are saying that like we are just utilizing the 5 millisecond. The frames are to be transmitted into the link to the maximally packed them in the transmit the link. Okay, you want to maximally pack it. That I agree. Okay, this is a duplex link. Frames of 1000 bits are sent over this. Second, since it is a duplex link, so why will it matter? I mean, I can keep on sending till I get the first AC. The propagation time is 25 milliseconds. Frames are to be transmitted into the link with the maximum. So to fully utilize the channel, we must send 10 to the power 6 bits into the channel. Yeah, that is the bandwidth. Yeah, to fully utilize the channel, we should be sending that many bits into the channel, which will be 1000 frames per second. Each frame is this. So yeah, to fully utilize the channel, we should be sending 1000 frames per second. But that's what we should be sending for 25 milliseconds, right? Since the propagation time is this, to fully pack the link, we need to send at least. Okay, I'm I'm in bit of doubt, like why that is just 5. If you take log of this, then what will that number? With 5 bits, you can just represent 32. I think you need 6 bits, right? But 6 is not even the option. The minimum number of bits that are required to represent the sequence numbers distinctly. Assume that no time gap needed to be given between the transmission of two frames. That is okay. They are saying, like in the solution, they are saying you just need to send till 25 seconds. But if you're just sending till 25 milliseconds, which means if you're just sending the packets, if you keep on sending the packet, that I agree, that's not a problem. You keep on sending the packet, right? You keep on sending the packet. After 25 milliseconds, what will happen? Your channel will be something, will look something like this. Your first frame will reach at the end, and your channel will look something like this. So after 25 milliseconds, that's, yeah, I agree, this is the situation, right? This is after 25 milliseconds. Now what will happen after it is that you are just sitting idle, right? You are here, you're just sitting idle, and you are waiting for the ACK to come. So see, what is happening here. Let's go to the next page. I mean, after 25 milliseconds, I completely agree this will happen. But after it, I mean, maybe at 25, or maybe let me just write it 28 millisecond. After, maybe after some time, which is 28 millisecond or something, then what you will do, this ACK is in the between. This ACK is coming. ACK is somewhere here. You are here. Your channel is here. I mean, channel will be just delivering the rest of the packets, right? I mean, you are just sitting and basically waiting for the ACK. That's the thing that I'm thinking, that why you're just waiting for the ACK. I mean, you should have, you should be sending, right? You should be sending. Why you are waiting? That is my only argument that I'm having here. Okay. So maybe one of the thing that I can guess is that it is a duplex link. Okay, since there is only one link, that is the only thing that I can think about it, right? So yes, I think there is only just one link. If there is just one link, then if it means that if this is sending the data, and since there is just one link, then once this is delivered fully, after that only I can start transmitting the ACK, right? Okay, I need to check it. What does this duplex link mean? A duplex link is basically is a communication system in a point-to-point system composed of two or more connected parties device that can communicate with one another in both the directions. Duplex systems are employed, so you can I mean, this is the full duplex or half duplex, that is also not given. I mean, they have just given that this is a duplex link. Not sure that they are talking about the full duplex or half duplex and what is this. So maybe I will just check this question. Okay, I'm not 100% sure that why they have not taken this RTT. They've just taken the propagation delay. That is not convincing to me at this moment, but I will check it. Let me just move further. If you have any idea, you can talk about it. Okay. So just go and read about it. It might be a nice exercise for you and for me also. Just look about it, like what they mean by the duplex link here, because it is not given that whether it is full duplex, half duplex. They have just said it is duplex link. So maybe we need to look at this. Okay, let me move further. No, this is the same question. Okay, in the same question they are asking about some more things, I think. So okay, so here they have considered. I think this will be interesting. So what they are saying, suppose that sliding window protocol is used with with the sender window size of 2 power I. Okay, so if I is sequence numbers, then they are saying that sender window size will be 2 power I. I mean, where I is the number of bits mentioned earlier, and the acknowledgement are always piggybacked. Okay, piggyback acknowledgement means like whenever sender is sending some data, along with the data you can send the acknowledgement. Okay, which means whenever sender needs to send, I mean, sorry, receiver needs to send some data, along with the data also you can send the acknowledgement. That is called piggyback acknowledgement. Generally we use the piggyback acknowledgement in case of TCP. Okay, so what they're saying is that let's suppose 2 power I is the sender window size. Okay, is the sender window size, where I is the number of bits as mentioned earlier, and the acknowledgements are always piggybacked. Okay, okay. After sending 2 power I frames, what is the minimum time the sender will have to wait before starting the transmission of the next frame? Ah, that's interesting. See, so in earlier question, I was saying that it has to wait because before starting, it has to wait for the ACK, right? So before starting the next transmission, if you are just sending this TP, see, if you are utilizing your 51 packets, if you are utilizing your RTT, if you are sending for the RTT, then you do not need to wait for even a microsecond. Why? Because the moment you are getting the ACK, see, if you are utilizing the complete RTT, then what does this mean? It means that you are basically sending something, sending, and you keep on sending, and then so you send many packets, and then basically the moment it starts the transmission of ACK, then also you keep on sending. The moment this first ACK will reach to you, right? So after a certain time, what will happen? Maybe after RTT, what will happen? Let me just tell you that what is the story. See, initially, I hope that is visible. Initially, this is the story where you have this. So initially, this is the story. This is initially, which means there is no packet and nothing. So initially, you have at t equal to 0. This is the story. You just want to send one packet. There is just one packet that you want to send. Initially, this is the story. Now, after RTT, what's going? Oh, sorry. After some time, which is TP, just after TP, then you will send. Your all of this will go somewhere here. Your first packet will reach here. This is the first packet that you send, and then after RTT, what will happen? After RTT, your situation will look something like this. See, you must have sent many packets, and many are along the way, and then the first ACK that you were sending, that is earlier it was here, the first ACK it was here, and then this first ACK is here now. Okay, after, you can say 2TP. And what about the other ACKs? Other ACKs are also here. Second ACK, third ACK, fourth ACK, fifth ACK, right? So other ACKs are also here. This is the second ACK. Now, if you're sending, let's suppose, so you're sending for 2TP, then this is the case, and let's suppose you're sending one more packet, which means the moment you absorb this, you will be sending one more packet. Basically, you are sending for 2TP plus TT time, right? If you're sending for this much time, then do you have to wait for the ACK? The moment you finish transmitting, the last packet, this is the same moment you finish absorbing this is the first ACK, right? So that's why if you are sending, keep on sending till the first ACK is completely absorbed, then you do not need to wait anything. Okay, I hope that is clear to everyone. But now they are saying that you are not sending. Suppose you are not sending till the first ACK arrives. You are just sending for TP time, which means after TP time your situation is like this. Okay, so which means that after TP time your situation is like this, means what? That this is this is the first packet. The first packet is not reached, is not completely absorbed by the receiver. So this is important to note. Suppose okay, that you are only sending for TP time. The second question is asking that if you are only sending for TP time, then what's going to happen? So if you are only sending for TP time, then this is the situation, which means that your first packet is here, and your first ACK, okay, sorry, your first ACK will be after the transmission time, but yeah. So then anyway that is okay. So your first packet is actually here, right, after TP time. Is this okay to everyone? So tell me, is this first packet get absorbed by the B, get completely absorbed by this receiver B or not? After TP time only, this first packet is absorbed by the B or not? Tell me. I think no, right? See, this after just to transmit one packet, maybe first packet or any packet, okay, just to transmit one packet and to completely get observed, it takes TP plus TT time. It takes this much time just for the complete transmission. So after TP, no, definitely no. But yeah, after TP plus TT time, right? After TP plus TT time, this will get completely observed, and then the ACK will get start transmission, right? So if you are just sending for TP time, then how much you have to wait till you get the first ACK? You have to wait till you get the first ACK. Basically, you have to wait for TP plus TT time, right? Because TP plus TT time is left till you get the first ACK. So if you are just sending for TP time, then the situation is like this, and now you are sitting idle. And how much for how long you need to sit idle? You need to sit idle for TP plus TT more time, right? Because total TP plus TT, which is 2TP plus TT, this is the total time that it takes. But if you're just sending for TP time, then you have to wait for this much time. So that's what they are saying, that suppose that is a sliding window, that whatever you are using is 2 power I. The sender is, let's suppose this is the window size. Okay, this is the window size for the sender, and then they are saying that what is the minimum time the sender will have to wait before starting the transmission of the next second. So which is TP plus TT. And what is TP here? I think you can calculate it. So what is TP? We might have calculated it. So TP is given to us. It is 25 plus TT. TT is easy, L upon bandwidth. Length is 1000 times power 3. and upon 10 to the power 6, and this will in the second. To convert that to in a millisecond, you need to multiply by 10 to the power 3. So I think this is just one. So 26, right? So 26, which is, I mean, TT is just 1 millisecond, so that's why 26 milliseconds you need to wait. So here this TP is 25 milliseconds given to us, and TT we just calculated is 1 millisecond. So that's why 26 milliseconds. Okay. So again, there is some mismatch in the answer. So the waiting time is equal to 52 minus 32 equal to 20 millisecond. Yeah, 52 is total RTD that we are taking. And why they are subtracting 32? For 32 milliseconds, the center was transmitting. Oh, so if we send this 32 frames, okay, they are saying that if we actually send this 32 frames, right? They are not sending for TP time. So here in this question, they are not sending for TP time. They are saying suppose that we send 2 power I frames, which means if I is 5, then if you are sending 32 packets, right? If transmission time is 1 millisecond, and if you send 32 packets, that's what they are saying, which means you take 32 milliseconds. You take 32 milliseconds total out of how many you have. The total RTT is 52, right? So basically the time that is wasted is 52 is total. Out of them you are actually using 32, which means you are saying that you are basically after TPC, after TP, which is 25 milliseconds, this will be the situation, but you are not sending till 25, you are sending more than 25. You are saying you are sending more than 25, which means that this is after 25 and this is after 32, because you are actually sending more than 25. So after 32 milliseconds, what will happen, that your packets will look like this. You must have sent some 7 more packets, so maybe this will look like this, and then you stop sending now, right? So here you keep on sending, but now you stop sending, stop, right? And then your ACK will look like this. So that's what they are saying, that this is the first ACK. How many ACKs will be there? Approx 7, I think, right? So 7 ACKs will be here, 1 2 3 4 5 6 7, something like this, right? So 7 ACKs will be here. So they are saying that you do not only send for 25 milliseconds, you actually send for 32 milliseconds. Or maybe you send 32 packets. Then how much time you have to wait? You have to wait for this much time only, right? This is the waiting time. Which means 52 is total time, total RTD, and out of them 32 milliseconds you are sending some packets. So 20 milliseconds you are actually waiting. So after 20 milliseconds, this will reach here, and then you will say that okay, now I got the first ACK, now I can start transmission again. So that's what they are saying. I hope at least the second question is clear, that what they are trying to say. The first question is still not 100% clear, in the sense that why they are just sending for 25 milliseconds, right? The second question is saying that suppose the sliding window protocol is used and the sender is sending, the sender window size is actually 2 power I, right? Where I is the number that we have calculated earlier. Then after sending 2 power I frames, they are sending actually 2 power I frames, they are sending 32 frames. What is the minimum time the sender will have to wait? So if you are sending the 32 frames, then this is the minimum time that you have to wait. Okay, let me explain once more. See, that's very easy. TP is given to us, which is 25 millisecond. Okay, TT is also given to us, which is 1 millisecond. Window size is given to us, which is 32 packets. Right. So these parameters are given to us. Is this okay to everyone? For the second question, at least these parameters are given to us. Now what they're asking is that how much sender have to wait. Okay, total RTT, tell me, total RTT is what? 2 TP plus TT. It is coming out to be 51 or 52. So propagation for this transmission, propagation for the ACK. Okay, ACKs are also having some propagation time. So that's why the total RTT ACK will now ACK is piggybacked and assuming the frame size and piggybacking also. So that's what one assumption that we did, that ACK is piggybacked. ACK piggyback means that you will be sending the ACK along with the data. Okay. So now we are assuming that that let's suppose the data that you are sending from another side is also the same, right? So basically, like there will be one more TT that is for the data that you are sending from the another side. Okay. And along with the data only, you will send the ACK. Piggyback means that along with the data, okay, whenever you are sending the data, along with the data, you have to send the ACK. So that's why there will be some transmission time for the ACK also, because this is not the transmission time for the ACK actually, this is the transmission time for the data, right? And along with the data, I'm sending the ACK. That's what it is happening. So total time is 52 milliseconds. Now out of those 52 milliseconds, since you are sending just 32 packets, that's why the total time that you are occupied, total time that sender is occupied is equal to 32 millisecond, because 32 packets and 1 millisecond is one transmission time, so 32 millisecond. So sender is free for how much time? Sender is free for 52 minus 32 equal to 20 milliseconds. Okay? That's what they're asking. Is this okay? Push space. In terms of window size also, like I have just explained it. Okay, so let's just revisit this question one more time from starting. What they're saying, they are having like they are having some bits and some bandwidth, and then they are saying that this is the frame size. The propagation time is 25 millisecond, and somehow we are just sending for 25 milliseconds. Frames are to be transmitted into the link, into this link, to maximally pack them in the transmit within the link. Okay, so I think this language mean that within in the transmit only you want to maximally packed. I think this language mean that you just want to send for the 25 millisecond. If you just want to send for the 25 milliseconds, then you just need 5 sequence number. In the 5 sequence number, you can actually send for 32 millisecond, or you can send 32 packets, but you're only sending 25. That's fine, right? So this is the first thing. Another thing that they are saying, yeah, that is actually the CN questions sometimes are a bit ambiguous or may not be 100% clear, and that's how it is. Like the subject is like this, right? So sometimes, rarely it will happen, but not always. I mean, here I'm again saying, like, I'm not convinced that why we are just sending for 25 millisecond. Maybe this line somehow means, okay, the frames are to be transmitted into the link to the maximally pack them in a transmit within the link. Maybe the line somehow means that we need to just send for the 25 milliseconds. Okay, again, like we will look at it later that why it is just for 25 milliseconds, but assuming that you are just sending for 25 milliseconds, in that case you just need 5. With 5 you can actually send for 32 milliseconds, but that's okay, that like you are sending for 25 milliseconds. Now the second question is saying that you are now actually sending for 32 millisecond, because the number of frames, the sender window is actually 32. Okay, so in this case, how much you have to wait? In this case, how much you have to wait? So acknowledgement are, they are saying the acknowledgement are piggybacked. See, acknowledgement are always piggybacked. Okay, always. Always means that you cannot send just ACK, right? You cannot send just ACK. You have to send ACK with the data. So that's why the ACK is also having some transmission time, because you have to send with the data, because that's what they are saying, that it is always piggybacked. So that's why, like, this is the total RTT, and this, since the acknowledgement is always piggybacked. Okay, piggyback means you have to send with the data. Now in this case your RTT will be 52 millisecond, and since you are sending for 32, so that's why it is 20 millisecond. So I hope this part is at least clear to everyone, that how it is coming out to be 20 millisecond. That is easy and very interesting, nice question. But yes, the earlier part, which is this one, right? Here, yes, I agree that that this TP, why we are just utilizing TP, is still not 100%. But let's leave it for now. Let me know if that is clear to everyone. So space, Ratul, is this fine? Okay. Now let's move to another question, which is this one. I think this is easy question, but still let's just solve it. So what they're saying is that consider a selective repeat sliding window protocol that uses the frame size of 1 KB to send data on 1.5 Mbps link. I think that is easy, and you should be able to do it. So they are asking about I think they are asking about the available sequence number or the number of bits in the sequence. Okay, so I'm leaving this question, probably thinking that you know it, or maybe I can do it also. So what they're saying, consider selective repeat protocol that uses the frame size. So frame size is given to us, which is 1 KB, and this is kilobytes. Okay, it is bytes to send the data on 1.5. So bandwidth is also given to us. Mega bits, it is given in the bits per second with one-way latency of 50 millisecond. So one-way latency means that the transmission time, sorry, propagation time is given to us is 50 millisecond. To achieve the link utilization of 60%. So can you tell me, just given these two numbers, can you tell me bandwidth into delay protect? Let's just to quickly find out number of packets. I mean, I can find out one plus 2a, which is the number of packets that you can maximally send, right? You can send 1 plus 2a, and if you just find out this number, the a is coming out to be 9.155. So 1 plus 2 is coming out to be actually uh, like, yeah. So a is coming out to be 9.155. So 1 plus 2 into 9.155. So this is the maximum number of packets that you can send. Number of packets. Now you can use the efficiency formula, which is efficiency 1 upon 1 plus 2a, and that is given to us, which is 60%, which is 60%. Then from here, what they are asking is that minimum number of bits. Yeah, so this is the window size. So from here you can find out what should be your window size, right? So just take the 60% of this. I mean, this is the maximum number of packets you can send, but you don't want to send this, you just want to send 60% of it. So just take 60% of it, then you will get this number, which is 11.58. So basically 11.58 is your 60% of the maximum packet that you can send. So it should be your window size, right? Your window size should be this. Sender window size should be this. Sender window size should be this. So which means that what should be the available sequence number? If your sender window size is this, then the receiver window size should also be this. So basically, I mean, in case of selective repeats, the sender and receiver window size is same. So it is the case, available sequence number. And then if you find out the available sequence number, that should be greater than equal to this 24. So you must be having more than 24 sequence numbers, right? At least 24 sequence numbers you should be having, then only you can have the center window size, which is this. I mean, it should be in terms of packets. In terms of packet, it will be 12, but yeah, that is fine. So which means that number of bits, minimum number of bits, you will be needing 5. With lesser than 5 bits, you can't accommodate this request. With lesser than 5 bits, you cannot have this center window size. So I hope that is fine. That was one easy question, as I told you. Let me know if there is any doubt till this point, right? Okay, let me just continue. So let's solve this question. Consider a network in that, I think this is also easy question. Maybe I can just leave this question for now. Okay. So let me just solve some good questions. Yeah, maybe let's solve this question. Just spend a few minutes to solve this question, and then we will be solving. So just spend a few minutes. Okay, so let's solve this question. What they're asking is that suppose that it takes 1 unit of time to transmit one packet of fixed size on a communication link. Okay, so the transmission time is given to us is 1 unit. I mean, they don't want to talk about the second, millisecond. Let's not worry about it. The link layer uses a window flow control protocol with a window size of n packets. So window size is given to us. Sender window size is given to us n packets. Each packet causes an ACK or negative acknowledgement to be generated by the receiver. So each packet, okay, for each packet you either have the ACK, which means if it is getting accepted, then it might be ACK. If it is getting rejected, then maybe it is an ACK or something, right? So you basically for each packet you send some ACK. And ACK or NAK, which is the negative acknowledgement, transmission times are negligible. So you do not need to worry about those transmission time. Further, the round trip time on the link is equal to n units. So round trip time is given to us is n units. Consider time I which is greater than n. Okay, so they're talking about the time which is greater than n, greater than the round trip time. If only ACK have been received till time I, no negative acknowledgement, then the good put. Okay, so basically there is no packet loss or something, so let's not worry about the negative acknowledgement. They are just given that just to confuse us. Okay, so they are saying that only ACK you are getting, which means there is no loss of something. Okay, so they are good put or throughput they are asking. Throughput evaluated at the transmitter at time I. Okay, so at the time I in packets per unit time. So how many packets you must have sent in this time I? That's what they're asking per unit time, right? So they're saying that uh, like you're talking about the time I. Consider time I that is greater than n. So RTT is n units. Now by the time I, how many packets you must have sent? So basically, how you calculate this? You will calculate that number of packets you have sent, in the time I upon the time the time that you had total. So total you had the I time. In this I time, how many packets you have sent? So this is the number they are asking, right? So they are saying that in this I time, how many packets you have sent? See, we calculate the throughput generally in 2TP plus TT time, right? In RTT time, because in this given time, how much we are doing, how well we are doing, that's define our throughput or the good put. So here they are saying at the time I, right? They are saying the good put evaluated at the time at the transmission time I. At the time I, what is the good put? Which means that number of packets you have sent at the time I. So just look at this carefully. This is what they're asking, right? They are saying that you take 1 unit of time for the transmission and RTT is n units, which means from here you reach here and the ACK comes, you take total of n units. So what do you think? How many packets you have sent in this I time? Can you send the I packet? Can you keep on sending the I packet? No, right? I mean, you can send only till the first ACK. So basically, uh, I think window size is also given to be n. So basically, the window size you can send in in one. I mean, in one go, we can send only n packets. Right? We can send only n packets, and I think that is fine because window size is given to us n packets. And yeah, so they are asking that if we are sending the n packets, then let's just see what's going to happen in the n units. See, you just send the n packets. Let me send one by one. Okay, so these are the n packets. Let's suppose you send the n packets. After n unit of time, you will be sending the n packets in how much time? in n time, right? Because one transmission time itself 1 unit. So you will be sending these n packets in n time, and RTT is also n. So which means after n time, what will happen, that you will be getting your first ACK, because RTT is also n. Your first ACK is here, and then you must have sent n of the packet, like whatever the packet you have. So after n time, you must have sent all the packets that you wanted to send, right? And your first ACK will reach here. Let me know if that is clear to everyone. See, what they're saying, that window size is n, which means you can send at most n packets, because the window size is n. Since the window size is n, you can send at most n packets, and after n time, what will happen? Since the RTT is also n, so that's why your first ACK will reach here. Now tell me that since I is greater than n, what you are doing in between? I mean, after your first ACK is received, what you are doing? See, this I is the time. Consider time I is greater than n. If only ACK have been received till the time I, no negative acknowledgement, then what you are doing in I minus n time, which means that after n time your this packet your this acknowledgement will be received, and then you have I minus m times with n time with you. So basically, yeah, just a second. Like they're asking number of packets that you can send divided by the total time that you have. Let me see what they're saying. So in a computer network, good put is the application level is throughput information, that's okay. So successfully delivery of the data can be assured if the ACK has been received for it. That is okay. So till time I, we would have transmitted I packets, but only I minus 1 can be acknowledged, as the minimum time for the packet to get acknowledged is n. Yeah. So for the first packet, it will come after the n time. We would have transmitted I packets, but only I minus n can be acknowledged, as the minimum time for the packet to get acknowledged is n. Since RTT is n, which is equal to the window size, there is no waiting time for the sender. Yeah, sender is keep on sending. So sender keep on sending, and sender is not waiting. So the successfully delivered packet is I minus n. Yeah, yeah, right. See what is happening here, that I mean, you don't know whether the all packets, which means the whatever packets that you have sent. So till I, so see, like I mean, the time you have time with you is equal to I, right? I mean, they are saying that after I time, what is going to happen, and what I want to calculate, the number of packets sent in time I upon time I, right? Upon I. That's what I want to calculate. So just to rephrase this, like actually I want to calculate number of packets packets acknowledged in time I, till time I basically. Because like in I time, I can definitely send I packets, right? I mean, no one is stopping me to send I packets. So basically, I we have sent number of packets sent is equal to I. We must have sent I packets, because at every 1 unit of time we are sending one packet, so we can send I packet, right? And no one is stopping us, because the RTT is n unit, and the window size is also n unit. So basically, I can send all of the n packets. I mean, whatever is the window, I can send the full window. So sender do not have to wait. So if I have the I time, then I can send the I packet. Number of packets I can send the I packet, but Is this the number of packets that have been acknowledged? No, right? So these many packets that I have sent in I time. Now tell me how many packets that you have acknowledged. Okay. So they are asking number of packets that you have sent, but number of packets that got acknowledged is equal to I minus n. Why? Because the first acknowledgement will come after n. So basically till n there is no acknowledgement, and after n the first acknowledgement come, and then after n how many till how many time you will be getting the acknowledgement? You will be getting for I minus n packets, right? I mean for the you can think about think like this, that you are sending the packets and initially there is no acknowledgement, but after n time you will be getting the first acknowledgement, right? And then you will keep on getting the acknowledgement. I mean you keep on sending, that's okay. See what is happening here. This is the timeline. You are sending the packet, you are receiving the acknowledgement. So this is the total time n, right? I mean you keep on sending the packet, you always keep on sending the packet, and you keep on receiving the ACK. So these are the ACKs, these are the ACK, and after n time this ACK will reach here and you will get the ACK. But it doesn't mean that you will stop your transmission, right? So this is after n time, this is n time, but they are saying I time. So after I time, I mean you keep on sending, right? You keep on sending, you do not stop, you keep on sending. This is I. So you keep on sending the packets. So basically you will be getting the first ACK after n time. So this is n. After n time you will be getting the first ACK. So you will be getting the ACKs for this much time only, I minus n time. I mean for this much time, for at every 1 unit of time you will be getting the ACK, because the transmission time is just 1. So you will be getting the ACK for every 1 unit of time. So basically for this much time only you will be getting the ACK, which means for these many packets till this total time, from the start to I, till this total time you will be getting the acknowledgement for just I minus n packets, right? So number of packets delivered till this point is I, number of packets delivered is definitely I, but number of packets get acknowledgement is I minus n. You don't know that other packets have been reached or not. So you can confirm that okay, I minus n is the packet you have sent in the I packet. Actually you have sent the I packet, but since the packet may lost, so that's why you are confirmed about only I minus n packets, right? I mean let me just give you maybe a simpler example. Let's suppose transmission time is 1 millisecond, okay, and RTT is n, and window size is also n, and let's suppose that I'm saying um, yeah I, let's suppose this I, so instead of n let me just take it 10. So let's suppose it is 10, RTT is 10 millisecond, and this is 10 packets. So instead of I, let me take that after 15 milliseconds what going to happen. So they are saying after 15 milliseconds what's going to happen. Let's suppose this is the case. See what's going to happen after 15 milliseconds. Let me tell you step by step. So what is going to happen after 10 milliseconds? See after 10 milliseconds, since RTD is 10, so after 10 milliseconds what's going to happen? You will start the transmission from here, and then this first bit will reach here, and then ACK, I mean ACK will also be starting for this first packet, and then your ACK will reach here, right? This is the ACK, first ACK. Let me write first ACK, and that's going to reach after 10 seconds. These are the 10 seconds. Till 10 seconds you are not getting any ACK. Now for the remaining 5 seconds, you are keep on sending the data. It's not like you are not sending the data, right? You keep on sending the data. For remaining 5 seconds, what you are getting, you get the first ACK, then you get the second ACK, you get the third ACK. So you get the ACK for these seconds only, right? You must have sent 15 packets. That's not an issue, but you must have acknowledged only 5 packets for this remaining time, right? I hope that is fine. So here even like this RTT is given to us 10 millisecond. So if you look at it more carefully, then you will say the RTT means that the moment you start the transmission till you get the first ACK. So I mean this first ACK must have been absorbed after 10 milliseconds. Your first ACK must have been absorbed, and then there will be a second ACK which is in which is after 1 millisecond, and similarly the remaining time is 5 millisecond. So in the 5 millisecond you will be getting total 5 packets. 5 packets will get acknowledged, right? So that is why the throughput is I minus n upon I. So I think, yeah, the answer should be 1 minus n upon, because actually the only point here is that how many packets you are confirmed that you have sent. That's the only point. Okay. So that was all about the selective window protocol, selective repeat protocol, and I think there are few more questions that we can do, but I'm just leaving those questions to you. And then tomorrow we will be starting error control, right? Tomorrow we will be starting very nice topic, which is error control. It is actually very nice in the sense that it is very tricky to understand that how these methods are working. I mean, especially the methods we are going to talk about is CRC and Hamming code. So I will tell you little bit of idea that how these methods are working, but I might not tell you the whole story. I mean, in the course, even I went talking about that how this CRC derivation works. I mean, that how what is the analysis of CRC is, right? Which means like we talked about that, okay, 1 plus x is one generator. Can it detect odd number of bits or not, and why it is detecting? That's very important. So we talked about the why things here. In Hamming code also we took two classes of 2 hours just to prove many things. So there also we talked about the why things, but in tomorrow's session I will keep it short. I will keep it whatever is required for the gate, so that you can solve the questions. Okay, if it is required, then only I will tell you some of the proofs. Otherwise I may skip the proofs tomorrow. So thank you everyone. Tomorrow we will be starting with this error control. Okay. So thank you. Take care.